Hello, my name is Alina Pruna. I present in this work a proposal of competency-based assessment tool for chemistry laboratory skills. It is the case of a study abroad students. The content of the work relates to the context, the previous works, the objective, methodology, results discussion, and conclusions. The context relates to the fact that the practical laboratory work in chemistry education is very important because the students deal with chemicals and instruments to develop competencies for the research industries. Therefore, the practical experimental activities play a main role in the science curriculum. It is known that the practical laboratory activities are centered on developing the skills to prepare an instrument for a required activity, to calibrate it, to work safely, to deliver results, to record the observations and collect the data, and analyze the data and draw conclusions. Therefore, specific instrumental competencies need to be evaluated. UPV Learning Results Project, developed in 2014, advised on transversal instrumental specific competencies like CT13 in this case, on different levels. It was reported that although the lab reports are directly linked to these instrumental skills, the lab grade do not represent the lab skills of the students, and a tool must be developed. On the other hand, the target student group must be smaller, so an improved evaluation could be produced. The objective of this work is to propose a competency-based tool to evaluate the lab skills of first-year students during a chemistry course. It is about student abroad students that have different backgrounds, and they came to University Politécnica de Valencia for the chemistry course. The competency refers to the management and the objective, the purpose of some experimental measurement instruments. According to UPV Learning Results Project on CTE13, the instrumental competency, the level of acquisition should be the first one because it refers to first-year students, which is focused on three outcomes: the identification of the instruments and their purpose, the ability to use the basic instruments following given instructions, and the application of the safety norms in handling the instruments. On the other hand, given the fact that the students have a different background, then the level 2 was thought to be interesting. So this one regards other two objectives: the ability to use the basic instruments in an autonomous way, and the ability to select and combine specific instruments for a given issue. In this case, we propose a tool that is based on questionnaires that are individual. They are proposed to a number of students of 17 that worked in teams of 3 students. The tool was was tested in 2 arbitrary lab sessions, like titration and heats of solutions, session 1 and session 2. The success level of each of the learning outcomes was divided in 4 levels, from D to A, that means from not achieved to outstanding. The learning objectives, according to the level 1 from the UPV project, are presented in the first table, table number 1. Table number 2 presents the learning objectives from level 2 that refer to the ability to use the instruments autonomously and to be able to select them and combine them for a given problem. And the tool that is presented in this work combines all the outcomes, assesses all the outcomes by using individual questionnaires, the lab report and the post-lab, since these refer to the ability to use the instruments under given instructions, the pre-lab and the checklist, and other individual questionnaires. It must be said that the questionnaires were available to complete after the laboratory sessions. They were individual. They were not considered for the final grade of the lab course, and there were different ranges to be considered for the success levels A, B, C, and D, from 0, 2.5, 2.55, 5.175, and 7.6 to 10. It was voluntary, and the response rate of the students was very good. It was about 88%. And by averaging the values for the all outcomes, it was revealed the success level of the competency in question for the two sessions. In the figure 1, I present the final laboratory grade and the competency value for each of the sessions, session 1 and session 2. It is observed that the final lab grade is much higher than the competency values. This is a trigger that must tell us there is a need to propose an evaluation tool, because the lab grade does not represent the laboratory skills of the students. On the other hand, the competency values for the two sessions vary a little bit because of the different complexity of the sessions. In figure 2, the success level for each outcome, it is analyzed with the grade ranges. That is, for each outcome, the ranges are presented, and we can observe that outcome 1, 2, and 3, representing the first level competency, it is achieved. That is, it is consisting in basically a range, and for both sessions, while outcome 4 and outcome 5 include also D range that is not achieved, and this is due to the fact that it is higher complexity and the students are not prepared, and it is obvious because they are first-year students. However, they have different backgrounds, and objective 4, for example, outcome 4, for example, it is well distributed, and it was considered interesting. In order to explain the results for the outcomes, a supplementary questionnaire consisting in a list of statements related to the experiences were distributed among the students. They responded on a 5-point Likert scale from strongly agreement to strongly disagreement, 5 respectively to 1 respectively. And the values, the mean response for each of the statement is presented in the table. For example, if the course materials help them to understand the subject matter, if the work that was required was based on the course objectives, if the course encouraged to think critically, or if the teacher stimulated the interest. It is observed that the mean responses were above the average. It is a good value. However, as it is observed, the students have difficulties in grasping the aim and understand the importance of the activities, which agrees with the outcomes from the previous figure. That says us that we need to have different activity levels for the laboratory procedures. In the following slide, I presented the conclusions that basically say the laboratory grade does not represent the competency skills, and the tool must be developed to this aim. It is proposed that different levels of difficulties must be introduced in the laboratory sessions. Thank you for the attention, and these are the references which were based on this work.